Hi all, welcome back to Computer Organization course. We'll get started. Today we will start with the third chapter, that is Basic Processing Unit, and here is the marks split up for that. In this chapter we will study how a processor executes an instruction or instructions, then the internal functional units of the processor and how they are interconnected with each other, microprogramming approach, etc. Okay. Before starting, we will just brush up some basic concepts. We had already seen the connection between the processor and the memory in the first chapter, right? Now, to execute an instruction, processor has to perform some tasks. So what are those tasks? So the PC, your program counter, would point to the first instruction in the program. The content of the PC will be then moved to MAR, that is memory address register. From memory address register, what happens? A read control signal would be initiated to the memory, and after some time lapses, what happens? The content of that memory location will be read into MDR. From MDR, it would be then the instruction would be then transferred to IR. Then if ALU is needed, any arithmetic or logical operation is needed, that would be performed and the result would be stored back to either memory or the general purpose register, right? So the first step here is to fetch the contents of the memory pointed to by the PC, and then after having all this MAR, MDR, the last step is the instruction would come and sit in IR. Now we can symbolically represent it in this way. The contents of the PC or the actual instruction, we have double square brackets here. So the actual instruction would be moved to instruction register. Now, meanwhile, when the instruction is getting executed, what will happen to PC? It would be incremented to point to the next instruction, right? So how can we do that? So the contents of the PC plus 4 will give you the new contents of the PC. That means that in this one, it would be pointing to the next instruction. Okay. Now, why we have added 4 here to the contents of PC? Because the assumption here is the memory is byte addressable and the word length is of 32 bits. Okay. Now, what is the third step? Once the instruction is present in the IR, it has to be executed, right? That is, carry out the actions specified in the instructions in the IR. If an ALU arithmetic or logic operation is needed, it would be performed. Now, what will happen if the instruction occupies more than one word? So till now we had seen the instruction would occupy only one word, that is 4 bytes. Now what would happen? Suppose instruction is present in consecutive memory locations, right? Two consecutive memory locations. That means 8 bytes, right? So how the instruction has to be fetched and executed? For that, what happens is your step 1 and step 2 here, right? This step 1 and step 2 would be executed as many times as necessary to fetch the complete instruction. Unless and until you do not get the complete instructions, this step 1 and step 2 will be repeated. Once you get the complete instruction, what happens? You can execute that instruction. Okay. Now, to study these operations in detail, we first need to understand the internal organization of processor. Now, we had already seen in the first chapter the main building blocks of the processor, right? ALU, control unit, then we had some registers. These are things we had seen. Now, these can be organized and interconnected in many ways. So, we will start with a simple organization wherein we have in this diagram we have the ALU and all the other registers are interconnected via a single common bus. Now, this bus we call it as internal processor bus. Now this bus is present inside the processor. Do not get confuse this with the external memory bus which we had seen in the first chapter. Remember we had a single bus wherein you had input unit connected to it, output unit connected to it, then you had memory and processor connected to it. Okay. Now this is a external bus. Again, from the first chapter, we had a concept, right? The connection between memory and processor. Suppose this is memory and this is your processor. We had some connections right here from MAR, MDR, and the control unit. Again, these three things will come under the same external bus. Do not get confused with this external bus and internal bus. This is internal bus, it is present inside the processor, and all these things, right, these things are present inside your processor. Okay, now the data and address lines of external memory bus are shown connected to the internal processor bus via your MAR and MDR. Okay, the register MDR, it has two inputs and two outputs. The data may be loaded into MDR either from the memory bus or from the internal processor bus. The data stored in this MDR may be placed on either of the buses. Then the input of the MAR is connected to the internal bus and its output is connected to the external bus. The control lines of the memory bus are connected to the instruction decoder and control logic. Now, these three things, address lines, data lines, and control signals, we had seen in the connection between memory and processor diagram, right? The same thing is explained here. That means the MAR, it gets the input from the internal processor bus and its output is connected to your memory bus via memory via this address line. What does the MAR contain? It contains the contents of PC. Where is PC present? It is inside the processor. Now the contents of the PC have to be moved back to MAR, right? What happens then? The contents of the PC are placed on the internal processor bus, and from this internal processor bus your MAR gets the address of the instruction. Now once the MAR gets address of the instruction, what it will do? It will send out a read signal to the memory, and this is your external bus. Okay, now once the memory address is referenced and after some time lapses, what happens? The content of it, that particular memory location, would be transferred to MDR, right? Now from the memory, if we consider this as memory, okay, some memory location is referenced and the content of that will be placed in your MDR through this data lines. Again, this data line is of external bus. Once the data is present here or the instruction is present here, from MDR it has to move to IR. Okay, so we had seen one input and one output of the MDR. The next one, if suppose the ALU has performed some task and the computation, the result has to be moved back to memory location, what do we do? The result from the ALU would be placed on the internal processor bus. Then from the internal processor bus your MDR gets the result, and then what happens? MDR will store the data into that particular memory location, again referenced by your MAR. You getting it? These two, MAR and MDR. Next, we had control signals, right? Control unit. What does it do? It manages the activity of your processor, entire processor, right? Now these control signals here, again these are connected to your external bus. Okay. Now these signals are connected to the instruction decoder and control logic block. Okay. Next you have here IR register. Again, it gets the input from your internal processor bus and it transfers that instruction to the instruction decoder and control logic, so that your instruction decoder and control logic, what does it do? It is responsible for implementing the actions specified by that particular instruction. Okay. Next we can see here R0 through Rn-1. These are general purpose registers here. What happens here in these general purpose registers? These can be used to store the end results or operand values. Okay, and some of these registers can also be used as index register and pointers. Okay, after this we can see here three more registers, this Y, Z and temp. These three are temporary registers. Okay, your processor will use these three registers to store temporary results. Okay, during execution, suppose during ALU execution or something, if you have a temporary result, then this Y, Z and temp, these three registers can be used for that purpose. Okay, now Programmer, as a programmer, you need not be bothered or concerned about these three registers. Why? Because these three y, z and temp, they will be never referenced in the instruction. Getting it? Next we have here mux, that is multiplexer. Now this multiplexer, what does it do? It takes either the constant 4 or the content of register y, and it gives the output, a single output which will act as one of the inputs for your ALU. That means this multiplexer, this mux, this has a select line, right? So if the select line is connected to this constant 4, that means what happens? This particular thing, whenever the constant 4 is selected by the multiplexer, that means the program counter has to point to the next instruction. That 4 has to be added to the contents of the PC. Suppose select y is done. Instead of constant 4, select y is done. Then what happens? Whatever the content of y, those things will be given as output to the ALU. Sorry, given as input to the ALU, not output but input. Okay. Next we have ALU here. The ALU gets it one of the input from this multiplexer and one input from your internal processor bus. Either that could be a operand that is stored in a register or from the memory location it will get here, and a particular operation is performed. Suppose add operation. So what we have to do, or what it has to do, the control signal add will be activated and restore will be deactivated, so that your processor performs the addition operation, and the intermediate result or the sum would be placed in the Z register, and from there it can be sent to the R0, or it can be any of these general purpose registers or whatever specified in the instructions. Okay. Now this slide, it will explain the same thing whatever we just now discussed. It says the same. Now this slide explains how an instruction can be executed by performing one or more of the following steps. So what happens while a instruction is being getting executed? So it can perform a arithmetic or logical operation and store the result in one of the processor registers. And what happens? The transferring of the data word from one processor register to another or ALU can happen. Fetching of the contents from a given memory location and loading them to a processor register, this can be done. Then last, storing a word of data from the processor register into a given memory location can also be done here. We have a quiz now. Say the sentence is true or false. The register Z present inside the processor is used to store end results of a computation temporarily. Tell this sentence is true or false. Your time starts now. Now let us see the register transfers. In register transfers, what happens? You can move the data from one register to another register. Now in this diagram, we consider if this Ri is a register, it's a general purpose register. Now I can be 0, 1, 2, like n minus 1. Okay, any one of these registers. So how the input and output, how the data would be loaded into the register and how this can be, the data of that register can be moved out, we'll see now. So here if you can see the register Ri, okay, this input and output of this register is connected to the bus via switches. The switches we call it as Ri in and Ri out. Okay. Now when this Ri in is equal to 1, that means when this Ri in is when this Ri in is set as 1, what happens? The contents from the bus are transferred to these registers. So whenever Ri out, if this is equal to 1, what happens? The content of this register will be transferred to the bus. Now this bus is an internal processor bus, and when this Ri out is equal to 0, what happens? This bus can be used for transferring data from other registers. Getting it? Suppose say that suppose we want to perform an operation wherein the contents of the register R1 has to be moved to R4. Something like this. Whatever the content of R1, it has to be moved to register R4. Now as per this diagram, we will assume that this is our register R1. Then if this is R1, then what would this switch will be R1 in and this would be R1 out. And consider we have a register R4 this side. Okay, so this is our register R4. Again we have switch here. Okay, so and this switch, input switch, we call it as R4 in, and consider we have output here, and that we call it as R4 out. Okay, so similarly wherein you have R1, right, we will consider there is another register R4 in this manner. Now you want to move the content which is present here. Say suppose the content of register R1 is 5, okay, or say suppose it is 50. The content of register R1 is 50. Now we want to move this 50 to register R4. How can you do this? So first what we have to do, we have to enable the output of register R1. This one. Enabling the output of register R1. What do you mean by that? That means R1 out should be set to 1. When this will be set to 1, what happens? The contents of R1 register will be placed on this bus. That means 50 would be present here in the data lines of this internal processor bus. Now 50 is present here, it has to be moved to R4. What do we have to do then? First, what we have to do here, R4 in should be set as 1. So whenever we set R4 in as 1, what happens? The content from the bus will be moved to the register, or content this 50 would be loaded into the register R4. Getting it? From R1 register, how we can move it to R4. Next, this slide, it will explain you the same thing which we discussed now. Again, yeah, this is also we have discussed, like the content of the register R1 to R4, how it will be moved. Okay. Here one thing we have to remember what is all the operation and the data transfers within the processor, it takes place within a specified period, and that period will be defined by your processor clock. The control signals that govern a particular transfer are asserted at the state of the clock cycle. So in our example, we had seen R1 out and R4 in are set to 1, right? Okay, this is 1, huh? Okay, these are set to 1. The register consists of these registers R1 and R4. These consist of edge triggered flip-flops. Hence, at the next active edge of the clock, what would happen? The flip-flops that contains R4 will load the data present in their inputs. At the same time, what will happen? The R1 out and R4 in will return to 0. Getting it? Okay. Next, we will check out the simple implementation for 1-bit register. So this is nothing but your one register. Consider this as Ri or R1. Okay, this entire thing is your register. This is input Ri in or R1 in, and this is R1 out, and this is actually the register. You can consider this one. We had seen in the last diagram, right? Wherein a register has R in and R out. So this has been represented here. So what happens here is this RI in, this switch, this is actually a multiplexer. Then the register itself is a flip-flop, and then this RI out is a tri-staged gate. Tri-stage gate. Now how the operation will be performed here? Now this two input multiplexer, it is used to select the data applied to the input of the edge triggered D flip-flop. Now when the control input RI in is set to 1, what happens? Whenever Ri in is set to 1, the content from the bus will be transferred to that of the register, right? Now, this data will be loaded here in the flip-flop at the rising edge of the clock. When Ri in is set to 0, what happens is this multiplexer, it feeds back the currently stored value in the flip-flop. So, whenever Ri in is equal to 1, the content from the bus would be transferred to that of the flip-flop. Then, when Ri in is set as 0, whatever the contents which are present in the register, it would be transferred back to the multiplexer. Next, we have this output, right? The output from the flip-flop, it has to be transferred to the bus. How can we do that? Now, this is the Q output. Now, this is connected to the bus via this Ri out. This Ri out is nothing but a tri-state gate. When Ri out is equal to when this is equal to 0, what happens? The gate's output will be at high impedance. That means it will be electrically disconnected state. So that this corresponds to the open circuit state of a switch. That means you cannot put the content onto the bus. So whenever this Ri out is equal to 1, what happens? The gate drives the bus to 0 or 1 depending upon the value of this output Q. Okay. Now these slides explain the same thing wherein we have discussed this diagram, right? The explanation is here. Next we have a quiz. So the question here is, what happens when the control switch Ri in is set to 1? Just tell me the answer whether it's A or B. Your time starts now. Okay, time up. Now we will study about how to perform a arithmetic or logic operation. So your ALU, it does not have any storage capacity. Okay, so what it does, it just performs the arithmetic and logical operations. And on what does it perform? It has two inputs, right? A and B. If you could remember the single bus organization diagram, this one. So you have inputs A and B. These two will be the operands for the ALU. It will calculate the it will calculate the result and gives back the output. Now, the result produced by the ALU, it will be temporarily stored in the register Z. Okay, So the result produced by ALU would be temporarily stored in this register Z. Now let's see how can we perform a operation. Okay, so we'll consider a basic example wherein uh, you want to add the content of register 1 and 2 and you have to keep the result in register R3. That is R3 is equal to R1 plus R2. Okay, the content of register 1 and 2 has to be added and the sum has to be placed in register R3. Now the instructions, how can you write the instructions? It is something like this: R1 out, comma Y in, R2 out, select Y, add Z in, then Z out, R3 in. Now how can we say these things, right? So let's consider this diagram and say suppose we have register R1 here, then say suppose register R2 is here and we have register R3 here. Okay, so we will consider something like this. This is R2, then we have register R3 and these are bidirectional and connected to the internal processor bus. Now the first thing what should happen? You have to move the content of register R1 to ALU, right? But ALU, how does it take the input? The first input has to be from this register Y and that has to go through the multiplexer and it has to come in A input of the ALU. The next has to come from this B register, B input of the ALU. So first thing what we have to do is we have to place the content of R1 onto the bus. That means from R1 you have to move the contents to Y. So how can you write the first instruction? The first step, what does it say? You have to move the contents of R1 out. Okay, so R1 out, this is the first instruction here, R1 out. Then from R1 out, whatever the contents of register R1 are there, where should it be placed? It should be placed in this register Y, right? So we write R1 out, comma Y in. Okay, R1 out, Y in. What have you done? You have moved the contents of register R1 to this register Y. Next, what you have to do? You have to move the contents of register R2. Where you have to move? You have to move to this B. Okay. So the second instruction says you have to move the contents of R2. So here R2 out, then you have B in. Okay. B in. Fine. Then what you have to do? One, the content of register R2 is here, but the content of register R1 is still here. You have to move it to the A, right? What you do then? First, you have to select the multiplexer. Select Y you have to do. Why? Because if you select 4, what will happen? The contents of the PC would be increased. If you select Y here, then from the multiplexer you will get the output here. So next is select Y. So next is select Y. Then what you do? Once you select this Y, what happens? The output of this Y will be present at this input A of ALU. Now you have got both A and B. The operands are present. So what is the next step? You have to perform this add operation. So the select Y, comma, the next thing is add. Okay, once the addition is done, then where you have to move the result? To this Z register. Again, if you would remember, we had two switches to the registers, right? In and out. So first what will happen? So once the addition operation is performed, it would be moved to register Z. That means it is Z in. Then what will happen? What was our operation? R3 is equal to R1 plus R2. You have added R1 plus R2 now. You have to move the final sum to R3. The last instruction would be, right now the contents are present in Z. You have to move out of that. So it is Z out, comma, where you have to move the final sum in register R3. So this is R3 in. So these are the instructions which will be used for addition of two register, the content of two register R1 and R2 and placing the sum in register R3. So what happens here? In the first step, the output of the register, let's just take this example, instructions, which is easy to see. So in the first step, what happens? The output of the register R1 and the input of the register Y are enabled so that the contents of R1 are transferred over to the Y register. In step 2, what you did, the R2, whatever the contents of the R2 is there, you have taken out, then you have selected the multiplexer, right? Then once you have selected the Y input of the multiplexer, it would be present at the input A of your ALU. Then you perform the addition operation and you move the sum to the temporary register Z. Okay, that's why here it is written as Z in. The last step, what it does, the contents of the Z are moved out and then be placed in the register R3. So this is how you can perform a arithmetic and logic operation. Okay. That's it for today. We'll conclude our session. Thank you.